Okay. Hariom everyone. Abhishek, can I begin?
Yes, ma'am. Yes, ma'am. You can start, ma'am.
Okay. Thank you so much. I could join. Hariom everyone from CBSE COA Patna. Today I'm going to take a session on a very important topic. It is, the CBSE has declared STEM education, as annual training theme for 2025. That's cultivating creativity and computational thinking in STEM areas. But before I begin, I just have a little prayer. Okay. ॐ सहना भवतु सहनो भुनक्तु सह वीर्यं करवावहै तेजस्विनावधीतमस्तु मा विद्विषावहै ॐ शान्ति शान्ति शान्तिः हरि ओम श्री गुरुभ्यो नमः हरि ओम. As already we all know that this is the theme of the year 2025. STEM education is an interdisciplinary approach to teaching and that integrates science, technology, engineering, and mathematics, STEM. It aims to develop 21st century skills that include critical thinking, problem solving, and many, many, many more, which I'll be discussing while taking the session. Today, I'm going to talk about objectives, meaning competencies, decoding creativity, integrating creativity and computational thinking, and leveraging tinkering labs and strategies for implementation. Objective. Objective of today's session is to equip teachers with an understanding of creativity and computational thinking in STEM. Strategies to cultivate these skills across different stages and how ATL can be leveraged. It aims to foster inquiring minds, logical reasoning and collaboration skills. Moreover, before that, I would like to say it also aims to give students the tools they will need to succeed in school, work, and hobbies. It's like a toolbox. STEM is like a toolbox. You might find sets of drills, ratchets, and wrenches, in a toolbox. Similarly, STEM discipline are like those little tools, and each tool is useful in its own right, but activities are needed. So, meaning of STEM, STEM. Okay, before I go to meaning of the STEM, just a minute. Objective, okay, engineering, yes, science, technology, engineering, and mathematics. They all engineering deals with the design, development, and construction of solution to problems. Electrical engineering, industrial design, mathematics provides the foundation for understanding patterns, structures, and relationship in the world. Applied mathematics, data science, and before I go to core competencies, I would like to mention that science and technology, these are the base of STEM education. I'll be highlighting in details the core competencies. You can see over here how you can peep through the core competencies and how you can develop the core competencies. As I said, that it speaks of 21st century skills. So to develop critical thinking, enhance creativity and innovation. Now, this is the era of innovation. Lot many innovations and creativity and innovation with computational thinking. We lead the students to tap their various skills. Yesterday I was talking about one of my ex-students. He was telling, Madam, I will acquire degrees, but what is important is skill. So the core competency of STEM is to develop skill. Whatever you learn, unless we develop skills in children, this will be not of much use. So let us develop collaboration and communication. Communication, you are well aware, is very, I'm not going to talk much on communication. This skill is very, very important. Collaboration, we need to work together, develop 21st century skills. 21st century skills include critical thinking, creativity, innovation, computational thinking, collaboration, communication, and many more. Students' motivation to design thinking. This is something very important. What is design thinking and how to develop? I'll be talking about awareness of AI. This is the world of, artificial intelligence. How to use judiciously and how to move further. That is important. Digital and technical literacy. Just I spoke about digital literacy and technological proficiency, inquiry skills and data literacy are the key components of STEM education. So its programs integrate technology into curriculum, This is important. Enhancing students' understanding of digital tools and their ability to apply them effectively. Important. It is very, very important. Why? Because STEM, as I said, science. STEM develop scientific temper, a modest, open-minded temper that is always ready to welcome new light, new knowledge, new experiences. So science is the core, a must for sustainable growth. If you want the children to grow, the growth has to be sustainable. And we need to develop science and scientific temper are the fundamental duties of Indian. Science stands for logics. Mathematics stands for analysis, logical. So these tempers and these abilities we need to develop in the children. It enhances a method of decision making in everyday life. How computational thinking helps us, to make decisions in everyday life. I'll be giving examples later. Okay. Now, importance of STEM. Future ready students. STEM prepares for a rapidly changing world of technology. Okay. And innovation. Critical thinking and problem solving. I spoke about that. STEM activities. See, I'm not using all the science, everything. I use STEM. Activities encourage students to think critically, analyze. This is very important. Analyze problem and develop, creative solution. I would like to mention that the 21st century skills demand new skills and ways of thinking. Technology now touches nearly every job sector, making STEM skills essential for scientists, engineers, and even for students who have taken arts, because everyday decision may STEM matters. According to Niti Aayog 2021, India Innovation Index, states have made notable progress in promoting innovation. Yes, even CBSE through various, conducting activities promotes innovation. Innovation, creativity. STEM encourages to think out of the box. It is not gone are the days of rote learning. Now the students to be tapped. Okay, so that they think. Let us not give spoon feeding. Let them think how to let them solve their own problems. It will not only develop their problem solving skills, but they will think critically. Ye nahi to ye, this nahi to that. How to move. So the students to think out of the box. That is that is why STEM is important. Resilience and adaptability. STEM education encourages the students to embrace challenges, learn from failures, and develop the resilience to adapt to changing situation. Well, I remember when earlier we had the computers, everybody said, "Arey, computer aa gaya, kya hoga, what about?" Then there was, smart classes. What will happen to teachers? Nothing. Nobody's role is going to be reduced. Rather, they are going to enhance their abilities so that the students develop differently. Okay, social emotional learning. STEM education promotes social emotional intelligence by fostering soft skill, as 21st century skills includes emotional intelligence, emotional balance, how the children can grow, not only physically, emotionally. That emotions very, very important. So STEM education promotes, when suppose they work in collaboration, they work together. What does it improve? What does it improve? It improves their social skills. When they work in groups, collaboration, one school, first in the class, then inter-school, then interstate, and that national and international. At every level, when the students work together in collaboration, they develop social skills, they feel emotional bond. That is very important. So they develop soft skills when they work with in STEM. So ultimately, this is the core of 21st century skills. STEM education helps them to develop valuable skills like communication, decision making. I spoke about importance of STEM, developing essential skills crucial for success. Engineering, healthcare. Healthcare is something, it is now upcoming branch. It is earlier people used healthcare kya hota hai? No, it has various aspects. I suggest the teachers to go through a website, okay, and look into various opportunities. Let us guide children how to they can move further. We cannot spoon feeding, but at least a little tap is important. real-world problem solving, to work on projects related to sustainability, renewable energy, or disease dissection. Coding and robotics. Coding is very important. Coding indicates those skills that can be applied broadly across many disciplines. Okay, while coding is often compared to learning a language, the skills learned in coding are actually more closely related to STEM subjects. Okay, so that's coding. It helps children to stick with a difficult task and abstract ideas. Okay, maths is hard, coding is too. But in fact, they need to learn. Okay, curriculum integration. STEM concepts are integrated into various subjects such as maths, science, engineering. Inquiry-based learning, leads them to innovation. Now here, the role of teacher is very, very important. How, there was a time, I tell you frankly, when I was a student, teacher used to give notes. Even we used to give notes when we used to teach. But now, let them inquire, let them think. Let them think on, you can guide them. The teachers are the facilitators. So let us encourage them to ask questions. Let them explore ideas and conduct experiments. Okay, and you must have sessions on experiential learning. These are hands-on activities. Hands-on activities on projects and simulations will definitely help the students to grow. Benefits. Now, before I go into benefits, I would like to mention that STEM education equips students with competencies that will enable them to overcome personal challenges as well. So, for creative solutions to difficult problems, STEM is important. Okay, like perseverance is important, resilience is important to success in almost every endeavor, and that leads to academics. The interdisciplinary nature of STEM encourages them to make connections between different fields and improves academic performance. Okay. Now, education is, different. It is activity oriented. It is not only knowledge based, but innovation, inquiry based. Example, learning about the life cycle of a plant, apply mathematical concepts to analyze. See, this is a simple, just example I have given. Apply mathematical concepts to analyze growth patterns. Use technology to create simulations and design engineering to optimize plant growth conditions. Okay. Cognitive development strengthens their cognitive skills, including logical reasoning, problem solving, and decision making. Very important already, as we all know, that hands-on activities they are exposed to challenges that stimulate their critical thinking and reasoning abilities. Let them ask why this happens. See, think of the person Newton, our scientist. He saw an apple falling. Why apple has fallen? And he, uh, theories and it become the call of the century. For example, again, second example I would like to mention, when building a simple circuit or designing a model bridge, children learn to analyze the problem, apply scientific principles, and devise creative solutions. So that is their cognitive development. Okay, not only they will develop their skills in academics, but they will cognitive development. Develops leadership abilities, offers high paying jobs that is later, but innovation is important that fosters diverse perspectives, equips them with competencies that will enable them to overcome personal challenges. Now, today's session, I'll be talking about creativity and computational thinking. What is creativity? What is computational thinking? And how these can be merged together for the development of skills. Creativity. Example, simple verbs are there. Okay, tell the students to see and write a paragraph. Again, he will think what to write. Somebody will say these are verbs. Somebody will say no, these are something different. Even you can ask the students something like this, they will answer differently. So creativity. Children are creative. Every child is born genius, said Albert Einstein. Every child is talented and creative. Though intensity of talent may vary, but it doesn't matter. Every child is creative. Give them, Play-Dohs. Give them something like clay and tell them to develop, sizes, patterns. They will do it. They will do innovatively. They will do different and encourage them. They'll be happy. Wow, I have done it. Okay, so let us tap the creativity of children. Let us not guide them wherever needed. Okay, suppose they are going off the track, guide them, but at the same time, let them explore their own. Let them, it will, tap their thought process. That is important. Okay, they are interested in everything. Give them a paper and a pen. Tell them to color. Look at the variety of colors they will do. Children I am talking about. And when they grow, it is different. But children are creative. See, we cannot say that when they grow, we'll do all this. It has to begin right in their formative years. Okay, creativity has to be tapped in the formative years. Give them paper and pencil, tell him to draw. Okay, don't tell him to draw a temple, to draw a bird, or to draw something, whatever. Let him see around and draw whatever he draws. He will tap the creativity. Okay. They are persistent and ask a lot of questions. This is important. Never discourage children from asking questions. Let them ask questions. Make original association using intellectual and artistic skills. Get pleasure. बच्चों को छोटे काम में बहुत अच्छा लगता है. They get pleasure out of simple things. Make them a paper board for them. Show them. He will do better than us next time. He gets pleasure. Okay, he snatches something and he gets pleasure. They get pleasure out of simple things. They are not afraid of possibilities. What will happen, they are least bothered. Whatever they want, they do it and allow them to do. They are not inhibited like adults. हम लोग सोचते we think to be done, not to be done, to do or not to do. They never think. So allow them. This will develop their creativity. That is what I'm saying. Creativity is skill in generation of ideas, products, novelty, quality, provide wisdom to evaluate. This is the best way. Artistic expression is the best way to develop creativity. You can see a chalk pieces, tell them, somebody will say it's green, somebody says it's blue, whatever they want to say. Somebody it is dusty. But at the same time, tell them to write a paragraph, they will write better. A small child, his perception is different. A teenager perception is different. Okay, but artistic expression can be different, but that is original. So let us tap the originality of children, collaborative creativity, mental creativity. Let them think, let them work together. Okay, person, process, and product. Creativity has three P's. Person is the teacher, could be a parent. Okay, process the way he does, and product, the final product is a child. How he develops creativity, what is the process he follows, how you are tapping, how you are encouraging, that is important. Okay, creativity is vital for innovation. That is why I was talking much about it. It demands classroom transaction, peer group transaction, and self-learning. It demands what if, perhaps if, why not, and why. Okay, so when they think, they will get the answer. Computational thinking. This is a problem solving approach, very important. A way of thinking that allows to understand, okay, solutions in a way that a computer, human, or machine can carry out. Computational thinking in a nutshell. Before I move further, you can see here so many, round figures over here. Some are small, some are big, whatever it is. So problem has been cut into various parts. Are you getting my point? Idea is understand complex problem and their solutions. Okay, and break the problem into various parts. Okay, you cannot jump to conclusion. Computational thinking is a problem solving approach. Break the problems into various parts. Develop solutions. Okay, design systems. Understand human behavior actions by drawing concepts from computer science. This is very, very important. Okay, enhances understanding of societal and personal challenges by providing tools. Okay, now thinking, key computational thinking, decomposition. Just now I spoke about that. Break down a complex problem into small pattern. Identify the similarities and patterns. What is the problem? What is the data? Collect pattern, abstraction, focus on essential information, important. Then algorithmic thinking. This is very, very important. Algorithmic thinking is developing a step-by-step solution to solve problem. Decompose, pattern recognition, abstraction, and finally it is algorithmic thinking. This last part is very, very important. Okay, now there are 5 key elements to computational thinking. Think abstractly, think ahead, think procedurally, logically, think and concurrently. Thinking process describes computational thinking, okay, as a set of three steps: abstraction, automation, and analysis. This also can be taken. Now, if these are some examples. Building with Legos. For small children, Legos is the best way. Magnetic tiles. Let them design the way they want. Or for other construction toys. Students naturally apply computational thinking. See, give them puzzles. Wonderful. You know, mix the puzzle and tell them to. Even elders cannot do it so easily. So building Legos, magnetic tiles are very, very important. They design and construct their creations and break down complex structures into smaller, manageable parts. This needs planning, problem solving. The students may not know what is planning, problem solving, but automatically by building Legos, they are thinking computational. They, they move for computational thinking. Okay, solving puzzles already spoke about playing games. From a young age, children develop problem solving. It is not that they grow and they start developing problem solving skills. Okay, from a young age, they develop. They analyze shapes and patterns. Small children, I'm talking about. They break down the puzzle into smaller sections. See, we are just trying to revise and revive. Revives, okay, the same thing, but in a different way, and develop a step-by-step approach to solve efficiency. These strategies become refined as they learn to recognize patterns in the puzzle. Identify corner pieces first. They join corners, followed by edge pieces, and then focusing on colors or design. How beautiful the example is given. Think of a child. It matters. Even when you go to the market, you will get the puzzles. Is it up to 7? Is it up to 10? 10 above, 12 above, 15 above, whatever. But the pattern is like this. Idea is let them tap their thinking skill. When a student encounters a problem with the design, whether a structure is unstable or parts don't fit together, they need to approach the issue systematically. Needs to reassess the design, find solutions, and revise approach. This process of problem solving, devising solution, this is for teenagers. Evaluate options and adjust their designs in real time, reinforcing the connection between creativity and community. These go together. These are together, creativity and computation. Unless child is creative, he cannot think. Okay, just a minute. Okay. The process of designing experiments, collecting data, and drawing conclusions follows a structured logical sequence. Example is here. When students innovate a new idea or even explore a new concept, often unknowingly apply the same thought process as they would do in a scientific experiment. They are unaware, but actually they are in the process of computational thinking. Okay. In mathematics, whether working through problems on a worksheet, solving real-world math problems, or using maths to solve personal challenges, they engage in computational thinking each time. They break down a problem and work through the steps required to find a solution. So already they are into it. They are already into computational thinking. Only we need to develop a little more enhance. The ability to organize information. See, this is for, uh, arts. Okay, they write a paragraph. Okay, you tell them to write a paragraph. The ability to organize information, analyze patterns, apply systematic steps to arrive at an answer is component of computational thinking. You know, when they write in academic writing, I was talking about writing a creative story or completing an academic paper, they organize their thoughts, structure their ideas, set up a plot, and unfold the process. Same thing. They are doing it. But if you give them homework, they might copy from a book available, but no. Tell them something different. Let them think over. Let them write down whatever they think. Let them organize their thoughts, structure ideas, set a plot, and then write their story. So writing in both academic and creative contexts to think systematically, and this is computational thinking. Every step, solving everyday problems. Computational thinking is present even in the most routine activities of everyday life. Organizing schoolwork, planning a bike route, deciding the best way to approach a task. Students are constantly engaging in abstraction. plan their after-school schedule by breaking it into chunks of time, organizing their toy. Even you, when you start coming to school, you plan out how what to do. You get up early in the morning before getting a, if you are a teacher, lady teacher, you have to do some household work. If you are a male teacher, you have to, attend some other calls of the house. Okay, and then so what I mean to say that we are in the process of computational thinking at every step. Organizing the students, plan their after school schedule by breaking into chunks of time, organizing their toys, collaborating with a friend. Okay, कहाँ जाना है? Do we have to play? Do I have to help mother? Do I have to help father? Do I have to go to my friend's house? Whatever. But they need to be systematic. Idea is computational thinking is a systematic approach to solve the problems. Okay. For problem solving, it provides a framework for approaching and solving complex problems systematically. Algorithm design, essential for designing algorithms, which are sets of instructions for computers to follow. Programming, computational skills are crucial for translating problem into a code that a computer can execute. This is important. Okay. Now, data analysis. Computational thinking helps in data analysis, interprets data into identify patterns. Software development. Computational thinking is fundamental to the entire software development. That is why STEM is a theme of 2025. We need to ponder over all these, look into all these, and start thinking in the lines. Okay. Design thinking. Design thinking I was talking about is a human-centered problem-solving approach that focuses on understanding user needs and creating innovative ideas. It is basically based on the needs of the person, what to do, how to do. It refers to a set of cognitive, strategic, and practical processes, okay, used in various business, education, and technology to develop feasible and viable solutions. Okay, this design thinking it has key steps: empathize, define, ideate, prototype. Empathize, understand the need of the person. Define what is the problem. Ideate, wide range of potentials through brainstorming. Prototype, creating tangible models to test and define ideas. And final is the test. This is the way of design thinking. First is empathize. समझना है what is the problem, what is the need. Then define, ideate. See, same, I have just structured it. Okay, although we are doing it, but we need to refine, not only refine our ways of working too. Okay, now, example I'm giving, Oral-B children's toothbrush, exemplified a comprehensive integration, not on of design thinking principles from empathizing to testing, creating a children's toothbrush that transformed oral hygiene into an enjoyable experience for young users, enhancing a toothbrush designed to meet children's needs. These are the examples of advertisement. So when we have to advertise something, you need to go for design thinking. You must be in school also. We all must be doing, have various sort of activities when we want to invite other schools. Then comes the design thinking. What are we planning? How to explore? How to invite? So it is not only oral B. It is in every step. You have to plan out and design. Okay. So now Netflix shuffle button is a prime example of design thinking in practice, recognizing that the vast area of choices of users, Netflix effectively removed the burden of decision making from the user's shoulders. Instead of spending precious time browsing through countless options, they can simply hit the shuffle button. Let Netflix give it a selection. Idea, these examples are given. You might have many, many more examples. And later I would love you to write a few examples of computational thinking. Anyhow, first I would like to finish my session. It adds an element of surprise, design thinking. Okay, see, you can see my slides also. I thought of, let me design it. I won't write like that. It's my thought process. What to do. Then I planned how to go. I went to the browser. Then I opened my, computer's laptop. I went into layout. Then there, how can I add picture? Again, this is a computational thinking. So every step life is a computational thinking. What you want to do something new, what you want to do something different, how you can break into problem, and how what is the outcome and how the results can be achieved. Okay. Now, decomposing creativity and computational thinking. See, again, these decomposing, these both are needed, both are interdependent. Okay. Creativity enriches computational thinking by encouraging exploration, experimentation, and development. And computational thinking on breaking down complexity, very clearly the difference. Creativity, innovation. Innovation के लिए experimentation. And computational thinking focus on breaking down complex problems. Recognize, computational thinking these two lead to innovation. Okay. And designing algorithms for, you have to think over how to move further. Now, computational thinking provides a framework for creativity and innovation. That's important. Innovations. Okay. Creativity fuels innovation. Computational thinking as a creative tool. Think of the scientific inventions. Okay, something has clicked. So breaking down complex problems into smaller, manageable parts sparks a new idea and innovation happens. So this 21st century is a century of creativity, computational thinking, and innovation. These are actually 21st century skills, alignment with soft skills. This is algorithm thinking. Sorry, I'll go back. Just a minute. Develop step-by-step solutions can encourage structured thinking, lead to creative solutions. Already I spoke about. Abstraction, focusing on essential aspects of problems while ignoring irrelevant details. Idea is that how to focus on essential. बाकी आप हटा दीजिए. Think of what is needed, what is important. Creativity as a driver for computational thinking. Novel ideas. Creativity can inspire the generation of new and imaginative ideas and exploring possibilities. Creative thinking encourages exploring different possibilities and solutions. See how creativity is important. Unless a spark comes, nothing can happen. Okay, that's a driver. And then computational thinking begins that leads to innovation. Okay. Yeah, this is what I was talking about. So creative approaches lead to innovative solutions that sometimes go beyond conventional methods and reaching application of computational thinking. We can't say what is done is done. Change is always possible. It can always be enhanced. Okay. Now, how to integrate this into classroom? Why creative education? Creation of more divergent thinkers in education, science, and everyday sphere to be able to solve complex problems. Creative education is important. Creative education, how to nurture creativity in the classroom, I will suggest through activities. So don't limit assignments to one format. Instead of limiting the student to writing assignment, they can create a podcast, video, role play, poem. This will not only develop their thinking process, but they will also, develop their creativity. They will also soft skills they will develop, which is essential in 21st century. Introduce unconventional learning materials into class. Conventional is okay. Everybody knows what different as a teacher we are doing. That is important. PBL is project-based learning and problem-based learning. Use creative and again critical thinking. Focus on developing conceptual understanding. What I want to say is concept clarity is very, very important. Unless the concept is clear, nothing will happen. Okay. And skills such as creativity, critical thinking skills, research skills are important. A dynamic student-centric approach as learning is driven by motivation. I still remember when I was a student, teachers would taught us differently. But now, with the change of time in 21st century, when we had no exposure of computers, we had no exposure of TV, we had no exposure of mobile, but now the students have exposure of everything. So they need to be taken more care. They need to be groomed differently. Children use mobiles, they know better applications, but how to turn them towards education, studies, that is important. So we need to keep a tap on the student. And What are they doing? And student-centric approach is very important. You need to motivate them. Okay. I don't say you stop watching mobile, no. Stop watching computer, no. But how? How we can guide them. Let them also think over, doesn't matter. Example of integration. This field explores how computational tools can be used to model creative programming. Okay, creative medium can foster both STEM education, integrate, this is very important, integrating computational thinking and creativity at every step can enhance problem solving skills, promote innovation and improve learning. Idea is integrating creativity and computational thinking. How to, there is a problem, how to get a step solution, that is important. Okay, in some activities, okay, some activities for the elementary student, step by step cards, pattern recognition with blocks for small children, debugging story time, flow chart fun, block based coding, robotics challenges, data analysis projects, algorithm design. You can think of some more. I just collected a few. Okay, these are for the elementary school. Give them blocks. Tell them to make various. Give them a paper. Tell them to make a flow chart. Okay, tell them to write a story. Simple thing. You went to yesterday to the market. What all happened? Write a story. Today, what happened from the morning till evening yesterday on Sunday? Write a story. Okay. So idea is let tap their thinking skill. Okay. For PBL, school, like redesign a common object, school bag. Creativity is brainstorm features, aesthetic material. When we plan for a school bag, what sort of bag we should have? It should be, I'm talking about small children here. Okay. Suppose they want to have a bag which has, so small that nothing can happen, or a bag which can hold pencil box, which can hold paper, whatever it is. Is the design okay? I remember we used to have a bag with the two straps on the shoulders, but now the students have one bag and they hold it, hunch, they have hunches. Okay. So what I want to say is time has changed. So even the school bag can have a session. The teachers can sit down and plan out, and then they can talk to the principal and apply it. Brainstorm session. Okay. Decompose current design नहीं चाहिए. Identify pattern of use, core functions, new design. Very simple thing. Okay. Solve a local environment problem. Okay. Campaign for cleanliness. Campaign for something good. Creativity. Ideate unique awareness campaigns. I was talking about collection methods. Okay. Some schools and some places, the students are collecting, food for the uh, poor children. Fine. That's also a way of campaign. Okay. Campaign not by going door to door, but the principal or the teacher, they guide the students how to help these people. Collection. Decompose the problem, find pattern. As I said, how to go about. It is not going from door to door. It is how it can happen that we need to think. Living, tinkering lab, STEAM. The STEAM I was going to talk about. We are talking about STEM. A stands for arts. Okay. And DY is do it yourself. That is leveraging tinkering lab. And ATL is a workplace established in school across India by the ATL Mission Niti Ayog in almost 8,000 schools across India. And I tell you, these ATL labs have, stimulated and fostered a culture of innovation. In our school, we have ATL lab. We're the first one to have it in our school. And there, what happened? The students made various patterns, and I correlate that they must have used computational thinking, they must have used innovation, and how happy they become when they do it. So this is actually hands-on learning. Tinkering lab, a space where they can come think out of the box, solutions of the problem, make designs. This tinkering lab also helps in design thinking. ATL Tape Lab is a dedicated workplace, often found in schools where I was talking about, where they explore, experiment, learn, and conceptualize scientific tools. It is a hands-on environment that encourages innovation, problem solving, and development. 21st century skills is important because it enhances, as I said, communication skills, collaborative, skills. It enhances creativity. These are the equipped tools, 3D printers, robotic kits, and all these are available. I don't, if you don't have, please talk to your principal sir or ma'am will talk to management and have tinkering labs in the schools. This is important because this is going to lead innovations. A dynamic and engaging environment where they transform ideas into reality, cultivate a passion for innovation, and that is the objective of STEM education. They have passion for innovation. It's a maker-oriented space to explore that fosters innovation, creativity, curiosity. Important. Developing design thinking by providing a space for learning, experimentation. So STEM is important. ATL is important because this develops passion for innovation. Okay. Now, hands-on learning, ATL, labs emphasize learning by doing. The teacher is just, facilitator. The teacher watches, okay, and the students learn by doing. So let us into that. Innovation and creativity, ATL is a platform for, as I told you, in our school we have, and there are a lot many creativity. अभी उनको लगेगा what is this? But when they grow, idea is seed has been sown. Now they will develop. Problem solving, tinkering labs encourage students to identify problems, brainstorm solutions. Again, this helps. The whole objective of STEM education is to allow students for innovation, creativity, hands-on activities through problems, developing problem solving. You can see a web on my slide. You can see why this web is here. This web is a plan to tap you that what you think of this and how you observe this, what is your perception and how you can guide students through this. That's why I have just put it like that. Many labs are designed to support STEM, yes. Iterative, process of building, testing, refining, which is crucial for developing innovative solutions. Community, and yes, sometimes you can involve community with the permission of the principal and collaboration. It fosters a sense of community where individuals can collaborate, share ideas, and learn from each other. This also will help the student go beyond. This can happen in the evening. If you have ATL, you can have in the evening the students who are in the school, their parents also can sit. So this is a way of community collaboration. Now, activities at primary stage. Primary stage grade to 5. Focus on tangible creation, simple problem solving, building simple machines with kids. Okay, this is for classes 1 to 5, simple machines. Okay, and creativity in design, computational thinking in sequencing steps. Now, middle scale, focus on design thinking, applying computational thinking to solve problems, programming, example, water level sensor for plants. Let them think of what is water level sensor, how to induct in schools, how to do it. Okay. And some schools which are having, exhibitions on science, I have observed there they have these sensors for plants. It is done. So creating, and I suggest all the schools must have science exhibition at various levels. Then you can promote STEM education better. Okay, exhibition at the primary level, exhibition at the middle school, high school, and plus two. It will explore them to various possibilities. Okay, then secondary, focus on advanced problem solving, innovation, developing projects with real world problems, developing of IoT, Internet of Things, okay, solution for community problems, e-smart waste management. See, various steps you have to think of what you can do. Creativity in system design. This is again very important. Programming and data handling. This is for the secondary. So you can have at 3 stages, not 4. Okay, 1 to 5, then middle class, and then 9 to 12, 5 to 1 to 5, 6 to 8, and then 9 to 12. Okay, so at various levels, we need to have 8-year activities, and I suggest for science exhibitions that will help them to make all. They'll, STEAM. STEAM is an approach to learning that integrates science, technology, and arts. Fine. By incorporating arts, it aims to foster creativity, innovation, and deeper understanding of how these subjects connect and apply to the real world. Do it yourself, that is DIY. Do it yourself. Activity of decorating or repairing a home or making things for a home yourself rather than paying someone else to do it for you. A DIY enthusiastic, a DIY project you can begin a DIY What not everything is possible, what they can do. They can, they can help the parents in getting ready for the school. What are the problems? They can note it down. What will routine after they go home? What they will do in school? See, even in the school, they can plan for, they can go as per computational thinking. What they should do. The teacher will come and teach after that what. So everything has a plan for computational thinking. So teacher as a mentor that encourages students, promotes collaboration, importance of documenting and learning journey. Creating engaging classroom. This is just a important in a nutshell. Making STEM relevant and relatable. Connecting STEM to real world problems and girls' and boys' interests. Encouraging active participation. Strategies to ensure that all participate. As I was talking about science addressing stereotype threat. Okay. I was talking about exhibition. That all the schools have exhibitions. You will have it. Science is a body of knowledge and a matter of inquiry. So collaborative projects are involved. When you go for the exhibition, projects will be there. Maybe class-wise, maybe group-wise, maybe house-wise. It all depends on the school. Maybe inter-school-wise, whatever. Okay. But it will help the students to think. Body of teaching strategy for science, body of scientific knowledge, practical activities to be strengthened. Let the children be curious and drive to develop the logical skills. Technology is used in various forms. STEM, S ho gaya, this is T. Technology is used in various forms. 3D printer, CNC is the computer numerical control. Okay, machines, robotics, IT, are just a few of the tools that enable creators to transform imagination into reality. Coding is very important, as I spoke in the beginning. E. Engineering is about designing, testing, building. So these skills are part of STEM curriculum and sometimes require software or other tools. They learn to use, CAD, CAD. CAD is, computer aided design, and CAM is, computer aided manufacturing. Okay, and CNC machines, all these can be computer aided designs. Maths skill for STEM include everything. They need to do some manual calculations. They should also know how to use powerful tools like patterns built in math library, probability, graphing, linear algebra, and tasks are fast and accurate with the right tools. Exposure to logics. This is important. Mathematics. They need to build practical skills, communication skills, learning skills, investigating skills, reasoning skills. Okay. Practical strategies, fostering a STEM-ready classroom. These last 3-4 slides are very important. Fostering a STEM-ready classroom, encouraging inquiry, valuing questions, creating a safe space for exploration is very, very important. Integrating creativity and computational thinking principle, using flowcharts for problem solving, breaking down tasks in any subject. This is a practical strategies for STEM in classroom. Because creativity prompts what if. Developing study habits for STEM. Understand the basics before diving into complex. Practice regularly. Use active learning techniques. Form study groups. Collaborative learning. Develop a study schedule. Use a variety of resources. Take regular breaks. Okay, it's important. Inquiry-based learning, this is very important. Just example I have given, you can plan out ocean literacy. Students explore ocean literacy. I'm talking of 9 to 12. Learn about the species commonly found on shore, food sustainability, and what can be done to protect oceans. Ocean literacy is defined as an understanding of the ocean's influence on you and your influence on the ocean. You can also think for mountains, importance of rivers, mountains, anything, any you can pick up which has inquiry based learning. I just gave an example of ocean literacy. As I said, you can pick up any like mountain, importance of, mountain literacy, geographical literacy, whatever. Then digital literacy is now a critical component of this already I spoke about. Robotics is a game changer for STEM robotics. Yes. The Atal Tinkering Lab is important. The integration of robotics in education is reshaping how they engage with STEM subjects. These programs equip them with technical expertise, foster support. See, idea is their mind will open up. This is important. Digital literacy, robotics. Okay. Then Teacher support, professional development. We teacher need to develop professionally. First, we have to, I have just taken session of 1 hour. Whatever you have understood, try to explore through various, windows. Okay. STEM specific training and reasons, collaboration, community engagement, parent involvement. These are parts. Okay. 4 components to the Cletra platform. Develop, play, share, and event. Allow students to explore as they build skills, and even when they create own game levels, allow them to explore. A playground to explore computational thinking, working through machines at the pace. Available for 6 to 12. Also online, these are available. You can look into that. Use of smartphone. This is a very good example. Use of smartphone algorithms power everything from unlocking the device with the facial recognition. All these are, things. On online shopping platforms, use recommendation algorithm to suggest products you might like based on your browsing. Navigation apps like Google Map utilize algorithms to provide real-time traffic updates. We should things are available, but we have to guide children how. Even in finance, they are employed for tasks such as fraud detection, automated trading, cybercrime. All these can be checked. Offline algorithms are sets of rules designed to solve problems. A recipe for baking a cake follows a precise algorithm, like the sequence of ingredients, steps to achieve. Traditional methods for solving puzzles, I spoke about. Making a cake, think of ingredients, again algorithm. So I put in the mind of students that computational thinking is a part of life. Use algorithms, that how they can break everything, nothing to be jumped over, everything through steps. Okay, this demonstrative how systematic thinking, this is very important, how systematic thinking and problem solving approaches can be applied in various contexts. This is important. Okay, everyday life. Many everyday algorithms are surprisingly complex, but they also come to us. For instance, deciding what to wear in the morning. Some of us, a complex algorithm of identifying what is clean and what is available, which options are suitable for the weather, which article of clothing match. Some are surprisingly simple, some are, very, crucial for matching. Again, this is algorithm. Okay, such as the process of pouring glass of water, line, whatever. Okay, it's a style that matters. Their algorithm plays a role. Okay. Tying your shoelace. A good example of this is every day ask a small child. There are limited numbers of steps that effectively result. Okay, like they have to, open the shoes, put it, tie and make a loop and do it. Following a recipe, classifying your. These are some bedtime routines. Finding a library book in the library has algorithm. Go to library. That library must display in such a way so that you can get it. Driving to or from somewhere, which way to go, what way to go, shall I take shortcuts? What I mean to say, every step algorithm is there. Focus on process, problem solving. So creativity, oh sorry. So creativity, collaboration, conceptual understanding, then there should be assessment. Authentic focus on applying knowledge and skills to real world situation, diagnostic assessment, authentic and diagnostic. Identify their prior knowledge and understanding before instructions to meet their needs. Way forward, computational thinking is not confined to technology or coding, but it is a process. Please, please, please remember this. It's a process that helps solve problems and make decisions in everyday situations. Computational thinking skills are valuable in various disciplines, including science, technology. By developing these skills, they can improve their critical thinking, analytical thinking, overall problem solving. What I have highlighted is most important. Okay. These courses for students, you can in digital promise, you can Google Explore, you can do that. Okay. Imagine, let the way forward, let us allow children to imagine, create, explore. Let us value their talents, new learning methods, podcast, TEDcast, internet, all these can be explored. Host an imaginary meeting, future trends, educational initiatives, supportive membership, and efforts to dismantle deep-rooted societal biases. That is our talk. Let us forget the shackles of the old society, old system. Let us put our shoes into the new system. Only by fostering an inclusive and equitable environment that nurtures the talents, we unlock the scientific discoveries and innovations. Important. And expect human excellence. Conclusion is, I'm just a great teacher, continuous learner. You all are great. You keep evolving, keep being proactive, keep inspiring, be disciplined, keep innovating, and develop love for the subject. You must expect your students to have an atmosphere of freedom and positivity, variety of activities, practice for diverse in thinking, promote experimental learning, use technology and aids. Okay, you are the key to the nurturing creativity. The entire school should be a learning lab. Children with a vision will surely become creative individuals, said Gurudev. So be yourself like a rubber ball and pant up to reach again the summit somewhere at the fall. Shed your tear. See, hurdles are crossed. You can see this rock. Similarly, let the children move forward. Okay, just a minute. I'll take 2 more minutes. Although I've shown this, but remember,
Hello. Yes, ma'am.
okay. Now here I stop the system. What I want to say is that you are the leader. You can do it. So from today onwards, keep on thinking what is computational thinking, how to move forward. Okay. Show me. Okay. I think I've stopped the video. Okay.
Yes, ma'am.
Now the important is thank you everyone. Any questions you can ask me. Any questions you can put in the chat box. I know it was strong subject, but we need see it is everything is old put into the new way so that we understand and how we can do it. We need to guide children. We need to tell them that they can do it. Tap the creativity. Allow them to ask questions. That will be wonderful. That will be wonderful. If they ask you questions, that will be uh, great. Just a minute. Yeah. If you ask them questions, that will be great. Asking questions is, it's, I'm there. You can ask questions, okay? You can ask me anything you want, okay? Anything, any question, please put in the chat box. I would love to answer. I have still 2 minutes more, but I can ask you questions. I don't know, but I wanted to give my, whatever I know about STEM. Okay, so we need to understand. Okay, any question? I would love to have one question if you want. No question? Thank you, Suresh. Thanks, everyone. Even I love to be with the region Patna because I belong to all of you. I am from Patna, so no question. Okay, okay, no questions. Okay,
Thank you,
so
ma'am.
then,
Thank you for the session, ma'am.
okay, Abhishek, shall I close?
Yes, ma'am. Okay, ma'am.
Okay. Thank you, everyone.
Thank you, ma'am.
Thank you, Saudya Patna. Thank you, Subhashri Madam. And thank you, Abhishek, you too, for cooperating. And thanks to all the participants. Thank you
Thank
so
you, ma'am.
much.